All right, let's dive into one of the weirdest, most fascinating ideas in all of science. We're talking about quantum entanglement. But first, let me ask you something. What if you had two objects that were connected, no matter what? You could move one, and the other one, even if it was on the other side of the galaxy, would move at the exact same instant. No delay. Sounds like science fiction, right? Well, in the quantum world, it's a reality.
So what exactly is this invisible, seemingly impossible connection?
Okay, at its core, quantum entanglement is when two particles become linked. They're essentially part of the same system. Think about it like having two connected toy cars. If you spin the wheels forward on one, the wheels on the other one, no matter how far away it is, instantly spin in a perfectly corresponding way. Now here's the catch you might be thinking of. This doesn't actually break the speed of light. You can't use it to send a message, because the results of any one measurement are always random. But the correlation between those random results, it's perfect and it's instant. And that's the scary part.
This whole idea was so bizarre, so completely against everything we thought we knew, that it really bothered the great Albert Einstein. He just couldn't get on board with it. In fact, he's the one who gave it its famous nickname, spooky action at a distance.
And Einstein's skepticism, well, it kicked off one of the greatest debates in the history of physics, a real clash of the titans. So on one side, you've got Einstein. He was convinced there had to be something else going on. He figured the particles must have some kind of secret note, hidden instructions they get right at the start that tells them how to behave later on. But on the other side was Niels Bohr. He argued for the true, deep weirdness of it all. He said no, the particles don't have a fixed state. They exist in this fuzzy cloud of possibilities, and it's only when you measure one that the other one instantly snaps into place. For decades, this was just an argument between brilliant people. But science isn't just about who has the better argument, it's about proof. And eventually, somebody figured out a way to actually test this spooky connection. It took a while to get there, though. So it all starts in 1935, when Einstein first raises his objection, and then nothing for almost 30 years. It was just a philosophical debate. But then, in 1964, a physicist named John Bell came up with a brilliant theoretical test. And finally, in 1972, John Clauser actually built the experiment to get a real-world answer once and for all. So what happened? The results came in, and they were crystal clear. The spooky link is 100% real. There is no secret note. The universe, down at its most fundamental level, really is that strange. And on this one very specific point, Einstein was wrong. Okay, so it's amazing to find out the universe is this weird. But the real question is, can we actually use this spooky connection for anything?
Yeah, this is the big one, isn't it? It's a mind-bending piece of physics, for sure, but what's the practical impact? Why should you care about any of this today?
Well, for starters, this spooky link is the absolute engine powering quantum computers. Entanglement lets them process information in a way that's totally new, allowing them to tackle problems in medicine and materials science that would take the best supercomputers we have today literally millions of years to even attempt. And get this, it also makes perfectly secure communication possible. Imagine sending a secret key using entangled particles. If a spy tries to intercept it and take a peek, the very act of looking at it breaks that fragile quantum link. The connection is severed, and you and the receiver instantly know someone's been listening in. It's like a spy-proof lock that's built right into the laws of physics. And believe me, this story is far from over. Quantum science is moving at an incredible pace, taking this discovery into completely uncharted territory. I mean, scientists are constantly pushing the limits here. Just recently, they've figured out how to entangle different kinds of particles, which opens up a whole new world of possibilities. And they keep setting new records for how far they can maintain this spooky connection, proving it works over bigger and bigger distances. So where is this all headed? Well, for a lot of people, the ultimate goal is to build a quantum internet. Imagine a global network that uses entanglement to link up quantum computers and sensors. It would be a system that's both unbelievably powerful and fundamentally unhackable. So let's just end on this thought. Entanglement proved that the universe is connected in ways we never, ever imagined. It really makes you wonder, if this profoundly weird link is real, what other spooky connections are still out there, just waiting for us to find them?